In this example, what we're trying to do is find some additional angle between 0 and 360 degrees that's going to have the same value as on part A, it's going to be the sine of 260 degrees. And in part B, it's going to be the cosine of 260 degrees. So they're nice enough to at least give us the exact same angle for both of these. What this all comes down to is understanding a little bit better about reference angles. And using them in the appropriate quadrants. So 260 degrees is the one we're going to be relying on. So what I'm going to do first is calculate what is that reference angle going to be. So just kind of place it in the appropriate quadrant. So I'll go ahead and put our quadrantal angles on here, 270, 360, and we're dealing with 260 degrees. So 260 degrees is going to fit into the third quadrant, 260 degrees. And it's really wrapping around all the way from 0 all the way around here into the third quadrant. Now, the next thing we want to do is calculate what is our reference angle going to be. So our reference angle is always drawn to wherever our normal angle, that 260 degrees, landed for its terminal side to the x-axis. So in our case, our reference angle is split up between 260 and 180 degrees. I'm going to call that reference angle theta bar for right now. All right, so it's composed of this red line, and then the blue line are kind of the sides of this angle. So to calculate what is that angle actually going to be, theta bar is you take the longer side, the 260, and you subtract away the shorter, in our case that's 180, and whatever this difference is going to be exactly what our reference angle works out to be. So 260 minus 180 works out to be 80 degrees. So it's 80 degrees for our reference angle. Let's use that next as we take a look at where is sine of 260 degrees. All right. We want to find an additional angle that's going to be the same as sine of 260 degrees. So the first thing I always look for is sine going to be positive or negative for 260 degrees? Well, we were in the third quadrant, and I like to use the phrase, all students take calculus, to remind me what's positive in each quadrant. So everything's positive in the first quadrant, sine, cosine, and tangent. Second quadrant, only sine is positive. Third quadrant, tangent is positive. So that means that because we're looking at sine is going to be negative in the third quadrant. Cosine will also be negative overall in the third quadrant. So let's use that, all right? Because sine is positive in the first and second quadrants, we're looking for what other quadrant is it going to be negative in, and we're just focused on sine for right now. All right, so sine was positive in first and second, but it's going to be negative in third and fourth. So the 260 that was already there is in the third quadrant, right? This was quadrant 3. We need to find a value in quadrant 4 using that reference angle. Okay, so to get that value in quadrant 4, basically we are going to use our reference angle to the x-axis and place theta bar in here, all right? Because we want to calculate this angle that wraps all the way around into the fourth quadrant that has that exact same reference angle. So what I'm going to do is I'm going to go ahead and start out with the x-axis value, which would be 360 degrees, and I'm going to subtract away that reference angle, which we said that reference angle was 80 degrees. So overall, we're looking at 360 minus 80 is going to be 280 degrees. That'll be an angle in the fourth quadrant that'll produce the exact same value as sine of 260 degrees. So we can be looking at sine of 280 degrees. It's going to be the exact same as sine of 260 degrees. They both work out to be negative, all right, because we're in third and fourth quadrant, where sine is negative in both of those. All right, next, moving on to cosine, it's going to be pretty easy because we've already done all the work to find the reference angle. Next, what we want to do is figure out, because cosine of 260 degrees is negative, because it was in the third quadrant, where else is cosine going to be negative? Well, cosine's positive in the first and fourth quadrants, but cosine is going to be negative in the second and third. We've already taken care of the third quadrant with the 260 degrees, right? This was quadrant 3. So we're looking for one in quadrant 2, where cosine is also going to be negative. All right, so again, pretty similar. Let's go ahead and we need 180 degrees. And then we're going to go ahead and place our reference angle, as always drawn from the x-axis, this time back into quadrant 2. And our end goal is to find this angle that wraps around from the x-axis on the right-hand side into quadrant 2. Okay, but remember that our reference angle was 80 degrees here. So what we're going to do to make this calculation is we're going to do 180, and then we subtract off that 80. This will give us 100 degrees, be an angle that wraps into the second quadrant. Remember, this is 90 up here at the quadrantal angle here. That's going to give us the exact same value as cosine of 260 degrees. Let's go ahead and fill that in. Cosine of, we said 100 degrees, will be the exact same as cosine of 260 degrees. They'll both end up being negative based on which trigonometric function we're using and which quadrants. All right, so a little bit of work to get those reference angles, but do understand how to use them in the appropriate quadrant. I think all students take calculus is really helpful to remember exactly which trig function is positive in which quadrant. So I hope this helps out. Good luck as you're working on these.